Integral by substitution method. We know that integral by substitution method is the inverse of the chain rule in differentiation. We need this method because sometimes we find it is difficult to integral a function using the power rule. That's why we have to do the substitution of the specific variable and the integrand. So let's see the first substitution. We will substitute in terms of u equals to ax plus b. For example, integral of x plus 4 to the power of 5 dx. So the first step, we have to substitute the function x plus 4 into u. So u equals to x plus 4, and then we can find the du dx is equals to 1. So from here, I can have du equals to dx. So now the question is changing into integral x plus 4 become u to the power of 5, and dx become du using the substitution. So this substitution method is to simplify the expression from the complex expression into the simple expression that can be easily to be integrated. So if you see from here, from the complex equation, we can simplify it into the simple form so we can integrate it using power rule. So substitution method means a method to simplify an expression to be integrated using the power rule. So that means we just integrate this using the power rule. So u to the power of 6, 1 over 6 plus c. So in here, we just replace back the u. So 1 over 6, x plus 4 to the power of 6 plus c. So this is the answer. So from this example, you can see that substitution method is a method that simplifies the expression so it can be integrated using the power rule. It changes from the complex expression into the power rule. Another example, integral of x plus 5 to the power of 7 dx. So using the substitution u equals to 4x plus 5, du over dx is 4. So du equals to 4 dx. So changing the expressions is integral u to the power of 7, and dx should be changed into du. So because du is for dx, so that means I can change it into 4 dx divided by 4. So that means I can have integral u to the power of 7 for dx, and then I move the 4 into 1 over 4. So it is 1 over 4. I can take out the 1 over 4 outside the integral. And in the integral u to the power of 7, the 4 dx is equals to du. So just replace it into du. So now we have the power rule. So it's 1/4 times u to the power of 8, 1/8 plus c. So it is 1/32 u to the power of 8 plus c, and then replace the u back to the original function, 1/32 4x plus 5 to the power of 8 plus c. Number 3. 1/1 minus 2x. By using the substitution u equals to 1 minus 2x, so we will have du over dx is equals to -2. Then du is -2 dx. So the expression now is changing into 1/u, and the dx, since we have -2 dx, I put -2 dx over -2. So I can bring the -2 to the front. So it's 1/2 integral 1/u, and the -2x is equals to du. So I change it du. So I can integrate it using the power rule. So -1/2. The integral 1/u is ln u. We give the absolute sign plus c. So it's -half ln, replace back 1 minus 2x plus c. So this is the final answer. Number 4. Integral e to the power of 3x minus 1. So u is 3x minus 1. Du over dx is 3. So du equals to 3 dx. So we can change the expression into integral e to the power of u, and then I make it into 3 dx over 3. So it is 1/3 integral eu du. Yeah, you do the same. 3 dx is equals to du. So equals to 1/3 integral e to the power of u is e to the power of u plus c. So it's 1/3 e to the power of 3x minus 1 plus c. So from these 4 examples, we can see that the idea of using the substitution method is to changing the complex expression into the power rule. So it can be easily integrated. Now, how do you know what function or which part that we have to express as u, that we have to substitute as u? So we have to know the specification of the function, especially for the power rule. Power rule means about integral ax to the power of n dx. If you remember, the rule of the power rule is this. So that means we have to simplify the complex expression into this form. That's why in the first example, x plus 4 to the power of 5 is simplified into u to the power of 5. So the one that we make into u is the one inside the bracket, x plus 4. Number 2, the same. We want to change the 4x plus 5 to the power of 7 to become u to the power of 7. So that means the u will be the one in the bracket, 4x plus 5. Number 3, we know that the identity of integral 1 over x dx equals to ln x plus c. So we try to make it into this form. So 1 over 1 minus 2x, I will change it into 1 over u. So 1 minus x minus 2x will be the u. So we choose that. Not 1 over 1 minus 2x, but only 1 minus 2x. And for the last part, because we know that integral ex dx is ex plus c. So that means we have to change the power su to have integral e to the power of u du. So that's the idea. How do you choose which part that should to being substituted? This is exercise, you can try it. The second form, integrating the form of g prime x gx dx by substitution of u equals to gx. In this form, the integrand consists of the derivative of a function. G prime x is the derivative of gx. So if we have this kind of function, we have to make the function as u, not the derivative. Yeah, the function itself should be substituted into u. Example, 2x square root of 1 plus x squared dx. We can see that 2x is the derivative of 1 plus x squared. So that means the one that we substitute is 1 plus x squared. So u equals to 1 plus x squared, then du dx will be 2x. Now see, you will see this form. This 2x will be equals to this. So I can continue. Du equals to 2x dx. So integral of 2x square root of u dx. And then I have to change that all into variable u. So I rearrange integral u to the power of half 2x dx. And we have that 2x dx is du. So I can change this into du. So integral u half du. So this is power rule. So we can just integrate it as using the power rule. So u to the power of 3 over 2, 1 over 3 over 2 plus c. So it's 2 over 3, u 3 over 2, and then we return u 3 over 2 plus c. And then we change back the u. So 2 over 3, 1 plus x squared to the power of 3 over 2 plus c. So we will have this expression. Number 2, 4x over square root of 2x squared plus 1 dx. We can see that the 4x is the derivative of 2x plus 1. So u is 2x squared plus 1. Do not take the power, the square root, the power of half. Do not take it. Just take the function inside. So du is 4x dx. So this is integral for x dx over square root of q. So the same thing for x dx can be changed into du. So this is du integral u to the power of negative half. So this is the power rule, and then we just integrate it using the power rule. So u to the power of half, 1 divided 1 over 2 plus c. So 2u half plus c. Or this is 2 to x squared plus 1 to the power of half plus c. This is the final answer. Number 3. In this case, we can see that 3x is the derivative of x squared minus 2. So u is equals to x squared minus 2. So du equals to 2x dx. So we can change this into integral 3x eu dx. And then how do we change dx into du? Du is 2x dx. So I have to change it into 2x dx, but I divide by 2. Integral 3 e to the power of u. Yeah, so I move the x, I move the position x to be linked with the dx. So from here, I can take out the numbers for 3 over 2 integral eu, and then the 2x dx can be changed into du. So it's 3 over 2. Integral eu is eu plus c. So it's 3 over 2 e x squared minus 2 plus c. So this is the final answer. This is also the exercise. You can try this. That's all for the integration by substitution. Thank you and bye.